26 years ago, I left Greece and embarked on a journey that has taken me from Salonika to here. Yep, I'm a rocket scientist. I launch rockets and I build space telescopes to try to uncover the mysteries of the sun. Why the sun? Well, I love space, and the sun is the most important object out there. It gives us life. And also, it's beautiful and fascinating. Some of our telescopes capture the corona. This is the sun's hot atmosphere of about a couple of million degrees. And as you can see in this month-long movie, the corona is seething with activity. Explosions and eruptions occur every few hours, releasing tons, billions of tons of material at the speeds of a few million kilometers per hour. And so trying to find why they happen, how they happen, and whether we should be worried about it makes for an exciting day job for me. But how did I get there? Well, while I was preparing for the talk, I started thinking back on the opportunities I encountered along the journey. And I realized something surprising to me, at least, that during my career, I keep applying 6 simple ideas over and over again to take advantage of an opportunity. And so I would like to share them with you. And I call them my own guide to opportunity nirvana. So first of all, you need passion. We need passion to go after an opportunity. Otherwise, why would you go after it? But then you really need a plan, and you need to think globally. I think those 3 ideas are fundamental for finding opportunities. And then comes the hard part. How do you actually be able to capture, to take advantage of an opportunity? And there you have to prepare. You have skills or qualities, somewhat talent, not much. And then reality sinks in. Sure, there are a lot of opportunities, but you have to be flexible to capture them. If you put yourself in a square box, you won't fit through a circle, for example. And then the final, of course, part is you find the opportunity, you have to dare and grab it. Otherwise, you will miss it. And so I would like to take you through my journey and to demonstrate how these 6 principles work for me every day, really. So my journey starts in high school. I was about 13, 14 years old, and I was already enamored with the night sky. I just loved space. And of course, I loved science fiction. So I was dreaming of space travel to exotic places in the universe, like black holes and exploding stars. So you can say that the sirens of astrophysics, yeah, they were already calling me, but I had not really a concrete idea what to do, as I grew up. And then I came across an article in a science magazine about a very large array. So the VLA is situated in New Mexico, in the southwestern United States, and is the largest radio telescope in the world. It consists of 27 antennas, each antenna the height of a 5-story building. So it's pretty huge. And some of you might know it from the movie Contact with Judy Foster. Well, what captured my attention was the way that it operates. You're familiar with the regular telescopes where you put your eye or a camera, you take a picture of the night sky. Well, that's not how that works. Here, you can actually make maps of sources millions of light years away by combining the tiny radio signals received by the antennas into a giant telescope the size of the array, which can be 60 kilometers wide. And so, being a teenager, I really wanted to do something different than everybody else. So I said, that's what I'm going to do. I'm going to do radioastronomy. And that sort of decision was key because it crystallized my passion for the night sky into a passion for black holes and gave me a concrete plan of action. I was going to go to the States, become a radio astronomer, study the mysteries of black holes, and then get to play with the giant radio telescopes. It's a pretty neat plan. And there you have it. This is really the three basic principles for finding an opportunity. All I had to do was get an opportunity, follow the plan. And follow the plan I did. I went to the University of Thessaloniki. In the physics department, pretty much ignored most courses that didn't really have to do with astronomy. I just passed them because I had to. And prepared, and that's what the prepare comes in, I prepared to figure out how to enter in a university in the States. So I had to improve my English. I'm still working on that. I learned what exams I had to take and find a few colleges to apply to. So when the time came, I took the exams, made the applications, and sent them to a dozen colleges, and waited. And then the letters start coming, and it was a rejection after another rejection after another rejection, sort of what an earlier speaker told about, until the 11th notice came from the 11th school, which was the one I really wanted to go, New Mexico Tech. I wanted to go there because it was actually at the VLA, and all the scientists and engineers working on the array were actually housed in the campus, on campus. And that letter actually was an offer letter. I was accepted in New Mexico Tech, so I was going to the VLA. I made it. And looking back to that, I think that I made it because I was prepared. I had really sort of figured out what I needed to do to get the fellowship. This is important because this was a major step. I went out of Greece, and I was, in a sense, the whole world was mine. And really, when a door opens, many more open, to paraphrase Bob Marley a little bit. And soon enough, I went to VLA, and one of the scientists asked me, how about working with me studying the sun instead of black holes? I'm like, the sun? I didn't even know that the sun emits in the radio. It doesn't sound that cool. And my subsequent advisor said, well, it's actually the VLA is the most sensitive telescope in the world. Few people know how to use it, but then it's going to be difficult to do a thesis because it's not really built for the sun. But in the end, you'll be one of the few experts around, and there's a lot of opportunities for discovery. So I thought, a challenge, and little competition when I graduate. So sign me up. So my advisor was correct. It was hard work. I spent many a night, spent many a night in the operation center, like this one is past midnight, trying to figure out how to make the array work for the sun. But in managing to get images of the sun like this, I learned a lot of valuable skills: image processing, instrument calibration, programming. But then, most important, I learned the value of patience and of persevering through difficult, until you find a solution to problems. And those were really invaluable for the subsequent career. And there you have it. So I left Greece to become a radio astronomer of black holes, and I ended up doing coronal holes for the sun. And actually, it was proven a success. And so that's my fifth step. I actually adapted to an opportunity that I was not planning to, and it was great. So this value of adaptation actually came back again very soon after graduation. I was at Caltech in Pasadena, California, doing solar radio astronomy, but I was, I guess, a nervous kid. So I was looking, I wanted to do something else. So I started looking for jobs. And then I came across an announcement from a federal lab, the Naval Research Laboratory in Washington, D.C., looking for young solar physicists working with coronagraphs, which are space instruments that they were recently launched in an international mission. So at first glance, I didn't really fit that description. It was space-based instrumentation. I was a ground-based guy. It was only open to the US citizens. I was only on a working visa. But then I thought, it's just solar physics. I'll just send them an email and ask. And I did send the email, and that email changed my life. I was thrusted unknowingly into the center of the solar physics renaissance that happened in the late 90s, because we had this ESA-NASA joint mission, SOHO, where we had the coronagraphs. We were really in the center of research at that point. We were discovering new things every day. How big are these explosions, masses, energies, where they come from the sun, in the sun, and more importantly, we started realizing the effect they have in our environment at Earth. But that's a discussion for a different talk. And this really made my career, and I'm loving it. I mean, I've been look at these images every day for the last 17 years. And I hope I'll do this for the next 20 years or so with my morning coffee. And although this sounds pretty exciting, and it was just the beginning. Soon enough, they asked me to work on a rocket program. I didn't know anything about rockets, but by that time, I was not afraid to say yes, why not? Then came a space instrument, then another rocket, then more space instruments, and the list hopefully will keep going on for the future. And all this, and so I ended up doing, having a very rewarding career, but quite unexpected in doing space hardware. I never planned for this. So all this was just because I sent that email. Actually, I was not afraid to go after an opportunity outside my comfort zone, which brings me to really the last step, to dare. If you don't dare, if you don't take risks, really you cannot make, you cannot advance, I think, as a person, because the experience matters more than success, if you like. And risks we do take. As scientists, we're really hyperactive bunch. We want to crack open the mysteries of nature, and two of difficult ones have to do with why the sun atmosphere, the solar atmosphere, is so hot, and why the solar wind is so fast. So it turns out that in order to find the answer to this, you have to measure things at the source, inside the atmosphere of the star. And so what do? We launch one. This is the mission, the Solar Probe Plus, to be launched in 2018, actually in 2 years. This is the most ambitious robotic mission ever undertaken by NASA. We will send a small spacecraft. Well, the movie should be... Anyway, we will send a very small spacecraft about twice my height towards the sun. We'll use Venus to sort of walk it slowly closer and closer to the sun until we enter the atmosphere. How close? 7 million kilometers. Now think, the sun is 150 million kilometers from us. So we're going to be 21 times closer. I know it is a big number. It's hard to get your mind around it, so I made a scientific simulation here. So imagine you're in the castle enjoying the sunset, which you could do if you didn't listen to me right now. And the sun will look like that. That's how the sun looks from 150 million kilometers. Now, if we were transported to the distance of 7 million kilometers from the sun, that's how the sunset will look like. It's not really sunset. It's going to be pretty hot. Actually, the temperature at front of our shield will be 1,500 degrees Celsius. Steel starts melting at that temperature. So we have those instruments, but then we want to see where we're going. So we have a telescope that we are building with our team. And of course, we cannot look directly from the sun. It's too hot. We have to look from the side. And so we build one. It's pretty small, about the size of a shoebox. And we managed to fit 2 telescopes in the shoebox. And that's how it's supposed to look like from about 35 million kilometers away. You see those 2 boxes delineate the field of view. Now, there's one more awesome fact about this mission. Solar Probe will be the fastest man-made object ever flown. When we are at the closest perihelion, at 7 million kilometers, we'll be flying at 612,000 kilometers per hour. At that speed, basically, you can order a pizza from here, fly to New York, come back in 1 minute and 20 seconds. It's great. So, and so, when we start looking at from that telescope, that's how it's supposed to look like. We'll be zooming in and out of the sun at extremely fast speed. Of course, here every second is 2 days. I make it a bit more exciting. But it is going to be very challenging. So this will be a mission like no other. And it will take observations like no other. So you can imagine the opportunities that we're going to have for major scientific discoveries about nature. So we're looking forward to it. So in closing, I hope you got a sense of how exciting space science can be. Sometimes I actually don't believe that I do this for a living every day. But I'm not unique. Many hundreds of our compatriots, and we saw a few of them today, do even more amazing things every day in the world because they take advantage of opportunities. And I believe they do employ those 6 steps. They have a passion about something. I like space. Somebody might like food. They have a plan. You have to have a plan. And you have to think globally, especially in today's world. This is really my main advice to the next generation. But you do have to prepare. You know, nothing comes without you spending some time and some sweat. Of course, you have to adapt because life, you know, it's a tough place. And there. And so my idea that I like to share with you is simple. Take those 6 steps and go explore this amazing world. Thank you.